Finally, we will create one machine learning application which will eventually lead us to deep learning. And in this application, we will actually recognize handwritten digits. We will simply follow a few steps. In our first step, we'll import the libraries TensorFlow and Matplotlib. We will actually import the pyplot library of Matplotlib. As we want to show image using Matplotlib, so we have to import inline Matplotlib using %sign and Matplotlib as inline. Execute it, and then let's load the data. For this application, for recognizing handwritten digits, we will use MNIST dataset, and it's under keras.dataset namespace. So tf.keras.datasets.mnist, and then we have to call the method loadData. Load_data. And now let's assign it in a variable. I'm naming it data. Now let's check the data, and we can see it has 2 tuple. So let's create 2 tuple and assign this data into 2 tuples. And inside every tuple, there are actually 2 sets of data. One for feature and another for label. Also, we can call it one for X-train and another for Y-train. And in the second set of tuple, the data is for testing. One for X-test and another for Y-test. Execute it and check the data of X-train. And we can see it's a 3-dimension array. Means it's a tensor. Let's check the dimension, and we can see it's a 3-dimensional array. Now let's check the shape. And we can see there are 60,000 sets of data, and every set has 28 rows and 28 columns. Let's check the first set of data. And we can see it's an array. It's an ND array with 28 rows and 28 columns, which is actually one handwritten digit 5. If we click on show data, then we can see it's one NumPy array with some values. And we have learned about it in our OpenCV section, that every image is an array and every cell holds one color. Now let's try to show this using Matplotlib. We can say plt.show X-train and the first set of data, and then plt.show. And we can see it more clearly this time. It's one handwritten digit and it's 5. What about Y-train? Let's check it. Y-train and the first data. And we can see it's 5. The label is 5. So we can see the data pair is perfect. In our first step, we have imported the library, and in our second step, we have loaded the data. Also, we have assigned this data into variables. And now, in our third step, we have to reshape this data. Because our artificial neural network takes data as single dimension vector, So we have to convert it, and our data is three-dimensional data. We can see it here. So we have to reshape this data. Because we have 60,000 sets of data, and every data has 28 rows and 28 columns, means every data has two-dimensional data. So simply we will make every set of data into single dimension data. As we know it's one NumPy array, so let's check the type first. We can see it's an NumPy ND array, so we can call the reshape method. And at our first argument, we have to pass how many sets of data we have. We have 60,000 sets of data, and in our second argument, we will simply say 28 row into 28 column. Now let's assign it in one variable. I'm keeping the name same and execute it. And then let's check the shape. And now we can see we have 60,000 sets of data, and every set of data has one row with 784 elements. And when we will train our model with this data, it will actually pass 60,000 sets of data, and every set will have one single vector with one single row and 784 elements. So in our third step, we have reshaped our data, and in our fourth step, we have to create our model. So tf.keras.sequential. We will use the sequential API. Let's name our model. I'm naming it handwritten digit recognition, assigning it in a variable, naming the variable model, and then I'm adding one layer, model.add, and I'm adding one dense layer for making one fully connected neural network. And I'm taking 50 neurons here. And we know our input shape is 784. So we will say input shape 784, and then let's name the layer input layer. Now let's add another layer. It also will be one dense layer, and it will be output layer. Because the number of digits are 10, so our possible output will be 10. That's why we want 10 neurons in our output layer. Name it output layer, and then compile it. First we have to pass the loss, and we will use categorical cross entropy loss function. Then optimizer, and we want it Adam, the Adam optimizer. And then matrix, and we will use accuracy here. So let's recap this step. In our first step, we have imported our library. In our second step, we have loaded our data. Also, we have assigned our loaded data in our variables for training and labeling. Then we have reshaped our data, and then we have created our model for training. So let's execute it and compile our model. Okay, I always do this. I misspelled it. Execute it again. And our compile is done successfully. Now let's check this summary. Awesome. We can see the summary. We can also check the plot model. We can say tf.keras.utils.plot model. Our model and show shapes equal to true. Okay, it will be show shapes. And we can see the plot model. And now let's train our model. And definitely we will assign it in one variable. I'm naming it history, then model.fit, then xtrain, and then ytrain, and then number of epochs. Let's say 10 for number of epochs. Well, if we execute this piece of code, then we will get an error, because we have to convert our ytrain data into one hot encode. Let's get the error first. We are getting the error, and now let's encode it into one hot. We can say tf.onehot and our data, and we want the array 10 by 10 because the number of neurons in our output layer is 10. Now execute it again. Okay, we got another error. So let's try two categorical method. It's inside keras.utils and then two categorical. And try to execute it once again. And we can see it's training. But it has failed with error. As the error is not friendly, so let's rebuild the whole code from very beginning. And till the training. And this time we can see it's training. And we can see some problem with training. So let's get the training history first. And we can see problem here in the data. So it's not possible to show the plot graph. Now let's go back to our model and try to find out the problem. We can see we have not added any activation function. For our input layer, we can use ReLU as activation function. So we can say activation equal to ReLU. And because there will be more than one output, so we will use softmax for our output layer. Activation equal to softmax. Now execute it again. Forgot the comma. And train our model once again. And we can see this time it's performing awesome. And we can see our accuracy is high and loss is very low. Now let's check the history. And now let's show the loss and accuracy using plot graph. So we can say plt.plot history and loss. And we can see our loss is decreasing gradually. It was about 2.5 at the beginning, and at the end it was about 0.2. Now let's show the plot graph for our accuracy. And we can see the graph of accuracy is also excellent. At the beginning it was about 70%, but at the end it was about 94%. And now let's do the prediction. For that, we can use our X-test data. So we can simply declare one variable and name it test data and assign the first set data of our X-test. Let's check it. We can see it's 7. Now let's predict it. And before predicting, we have to reshape it. We can say test data dot reshape, and we can say 1 by 784. Assign it in a variable. I'm keeping the variable name same. Execute it and predict it. And assign it in some variable. I'm naming the variable predict. The prediction is done. Now let's check the data of prediction. Because there are 10 handwritten digits, so the possible output will be 10. That's why it has shown 10 data in the output. And if we look at the data, then we can see the highest possibility is for 7. And we can get it using the argmax function of TensorFlow's math module. But before that, if we look closely at the output, we can see it's a 2-dimension array. So we have to make it 1 dimension first. Simply we can say predict and index 0. And now we can see it's 1-dimension array, means it's vector. And now we can say tf.math.argmax and our predict index 0. And we can see it has returned 7. And also we have tested that our data was 7. Well, if we use the argmax function of numpy, then we don't need to convert this array into single dimension. So simply we can import the numpy and call the argmax function and pass our predict and execute it. And we can see it has returned 7. Now let's save the model. Name it handwritten digit recognition.h5. Execute it and save it. And it's saved in my local device. Now let's add a new notebook, upload our model, and I have downloaded one handwritten digit from internet, which I will upload. And you can upload your own or you can use mine. Now let's import TensorFlow and OpenCV. Execute it and read the image using the imread method. So cv2.imread. And here we have to pass the file path with extension. So copy path, file path with extension as a string, and assign it in a variable. Check it, and we can see it's one 3-dimensional ND array. And if we want, then we can also check the dimension using the ndim property. It's a 3-dimension array. So let's convert it into grayscale. Simply we can say cv2.cvtcolor the image and cv2 dot color underscore bgr to gray. Assign it in a variable, execute it, and check the image again. And this time we can see it's two-dimensional array. Let's check the shape and let's check the dimension. And now let's resize our image and make it 28 pixel by 28 pixel, because our model is trained with 28 by 28 pixel image. So cv2 dot resize image and the size. We have to pass the size as tuple 28 by 28. Assign it in a variable, execute it, and check it again. Awesome. Now it's 28 by 28. But still it's two-dimension array. And we have to reshape it. Simply we can say image.reshape 1 and 28 multiplied by 28. Let's check the image. Okay. We forgot to assign it in some variable. I'm keeping the variable name same. Execute it again and check it again. And this time we can see it here. So let's check the shape. And we can see the shape is 1 by 784. Now let's call the model. Let's load the model. tf dot keras dot models dot load model. And our model path with extension. Copy path. Let's name the model new model. Execute it. Okay, it will be models. And then predict it. And here we have to pass our image. Assign it in a variable. Execute it and check it. Now let's call the argmax method of math module tf dot math dot argmax and pass our predict as vector. And we can see it has predicted 4. That's all about it. In our next section, we'll learn about convolutional neural network, and which we will use for rest of the projects.